Hello all, welcome to the Azure Data Engineering Demo session. Before we talk about the Azure Data Engineering for the day, let me introduce myself. Myself, Rajesh Kumar Nachagari. I'm a Microsoft Certified Data Architect with more than 15 years of experience into the data and analytics platforms with various domains experiences like banking, insurance, healthcare, with expertise of the different technologies like Microsoft BI, Power BI, and Azure Data Engineering and AWS and the GCP, etc. So before we get into the Azure data engineering, first we need to understand what the data engineering and how it helps the businesses to accelerate their processes. Data engineering is a process of collecting the data from the various source systems and integrate them by applying certain business rules and the transformations by cleaning up the data and storing them into the databases, which will be used for the analytics purposes. That's the core responsibility of a data engineer. So here, if you observe here, the customers can store the data into any of the format, right? They may be storing the data into the file systems, right? Probably like CSV files or the JSON files or the Pocket files or Excel files or flat files that or TXT, or they may be storing their data into the databases. Might be your Oracle or SQL or MySQL or DB2 or any of the databases. Or they may be storing the data into the applications like the SharePoint or Salesforce, etc. They may be storing their data into the any physical drives or the network drives, right? Or they may be storing the data into Cosmos DB, which is a document DB, or NoSQL databases like MongoDB, or might be storing into just on-premises drives, right? So customers can store the data into any of the systems. So being a data engineer, our primary goal is to get the data from these systems and you need to perform the ETL activities, extract, transform, load. You're going to get the data from the systems and you're going to extracting and transforming and loading the data into the standard databases. This is your database, right? On top of the database, we are going to build in another data warehouse okay? On top of it, we are going to build the analytics platform where you're going to perform analysis or analytics, right? So if you observe here, once I'm getting the bunch of data files from the customer, I'm going to work on the data cleansing activities. Probably your file needs some filter criteria. Your files needs any new columns to be derived. Any of the transformation logic, any of the data cleansing activities will be taken care in the ETL phase, and data is going to store into your databases. Once the data is available in the databases, we are going to build the data warehouse. So here you need to understand the two differences here. What is meant by database? What is meant by data warehouse? Database is a collection of data which is in the transactional data, is nothing but the day-to-day data which you're getting and storing into your databases. And whatever the data which is being stored into the database, on top of it, by reducing the granularity, we are going to improve performance by making it to the denormalized form. So for example, if I give you a layman example here, so there would be a customer, which is your customer ID and the customer name, and he's doing certain transactions, transaction type, and the transaction amount, and finally the transaction date. So these are the 5 columns that I'm considering. Let me try to. So you see here, 101 is a customer ID, and customer name is something like the Steve. Transaction type, he might be doing some sale transaction, and transaction amount worth 150 bucks, $150. And the transaction date is 2025 11 some 9 a.m. Right. Similar way, so the same customer 101, he made another two transaction. A name. Similar way, the same customer made another cash transaction worth 250 bucks in 2025 at 12:30 p.m. All right. Again, another transaction, which is credit card, $300 at 3:30 p.m. Okay. Now, the same customer again made another internet banking transaction, which is again $100, 7 p.m. If you observe here, for one customer ID or one record, you have the 5 different transactions that the customer made, which is a different transaction type. Some of them are cash transactions, some of them are UPI transactions like Jelly, and some of them are the credit card transactions and the internet banking transactions. So when I'm storing this data into my databases, I'm going to store that at very lowest granularity as your time. So the time is your lowest granularity. Granularity means the lowest level of accessing the data. In this context, I'm going to access the data at each and every hour level. But when I'm trying to store the same way for over a year of time, then the data is going to be super huge, right? So that's the reason we try to reduce the granularity here and we improve the performance by making it into the denormalized format. So when the same data, when I'm going to store into my data warehouse, I will prepare or I will make my data warehouse tables in such a way that it should consider the customer ID and the customer name and your transaction amount and your transaction date, right? Only these are the 4 columns that I'm gonna consider. Customer ID is 101. Customer name is Steve. And the transaction amount, you see here, I'm trying to skip this transaction type here. Just I'm going to consider the amounts. Together it is your $1,000. And the transaction date here, when I'm storing in my relational databases or in my staging databases or in my database, the transactional databases, I used to maintain the data at the hour granular level. When I'm moving that into the data warehouse, here I'm going to store that at the day level. So the data will get accumulative or the cumulative here at the day level. So here I'm going to write it as 2025 1105. So I'm not going to consider the hour here. If you observe, I'm not considering the data at the hour level. So whenever you increase the granularity, that improves the performance by accumulating the values here, right? So instead of having the 5 records per customer in the transactional database, after you move the data into the data warehouse, you will be having 1 record for the customer, which is a cumulative or summarize of your data. This is how you will be building the warehouses. It's not only just I'm giving an example, like it is the way the process that accumulate or summarize the data with a specific granularity by splitting them into the different dimension tables and the fact tables. And once the data is available in your data warehouses, on top of it, we are going to do certain analytics, which will be used as a metrics or the KPIs to be displayed in your report for the end users accessibility. So once your analysis get ready, then there would be a set of audience who will be connecting to your reports or your data sets. Say the end users will connect to your analysis platforms. So here, if you observe in the entire process, I did not use any word of Azure or AWS or the GCP or any of the system. This is the process. It doesn't matter whether it is on the on-premises or on the cloud. Only the thing would be when we are talking about the cloud, we are not going to install any of the softwares on our system, which is everything that we are going to get as a service from the cloud service providers. So if I try to replicate this entire system with the Microsoft Azure, then the storing this data, it could be a database files or it could be the file system files, or it can be any kind of a data which you're going to process. That comes under a service called storage accounts, which considers both the services. One is called the blob, second one is called ADLS, Azure Data Lake Storage. The first service is your storage account, where it is going to cover both the services. One is called the blob, binary large object. Second one is ADLS. In short, we call it as, but elaborated way, it is Azure Data Lake Storage, which helps you to store the data into the Microsoft Azure. So once the data is available into your storage accounts, then we are going to use another service called Azure Data Factory. This is Microsoft Cloud ETL platform, which connects to the different systems or different source systems, and it gets the data and transforms and load the data into the Azure SQL Server, which is a Microsoft Cloud database. Once the data is available in the Azure SQL Server, on top of it, you can build the data warehouses by using another service called Azure Synapse. Once it is available in your data warehouse, on top of it, again, we are going to design certain analytics by using a platform called Azure Databricks. Azure Databricks. So Azure Databricks is a platform where you're going to use the 4 different languages, which is your Python, Scala, R, and SQL. We will be using these 4 languages to write your piece of code in the Azure Databricks, which helps you to get the results, do the analytics, share the results with the users. That is how the Azure Databricks will help you in getting and predicting the results effectively. So then whatever the results is being shared here will be used by the end users. If you observe the services here, storage account, which helps you to store the data, Azure Data Factory to perform the ETL activities, Azure SQL Server to store the data, and Azure Synapse is to build a warehouse on top of the source data systems. And finally, we are going to use the Azure Databricks to predict the analytics and doing some analysis on top of the data which we are getting or which we are processing from the customer. Now, as part of the course, we are going to cover Azure Blob Storage, Azure Data Lake Storage, Azure SQL Server, Azure Synapse, Azure Databricks, and Azure Data Factory. In order to store the sensitive information, here we are going to use another service called Azure Key Vault. Okay, we are going to cover all these services. Along with this, we are going to cover Azure Fabric as well. Azure Fabric is the one which is a consolidated all the services. You can build the pipelines, you can store the data into the one lake. You do different, you can build the reports as well in the Fabric. Fabric is a one-stop solution for all kind of analytic needs. So that's where once we are going to start with these services, once we are done with this, then we are jumping onto the Azure Fabric where you're going to build the notebooks, pipelines, one lakes, right? You can visualize the data. We do a lot of stuff in the Microsoft Azure Fabric. So this is going to be covered once we are done with all the context here, because there are the two kind of projects in the market. It's not always all the projects on the Fabric. Microsoft Azure is a very old legacy and it's been like quite long time in the market where it has the different services projects are being used, right? So if you're working on the migration project, the project would have been started and there are a lot of services which already been using. So we should understand how these processes first, how these services working first before you be jump onto the Azure Fabric, right? So Microsoft, all the data engineering services will be covered at first, then we will be jumping onto the Fabric and our training will be focuses on the development as well as the migration. Once we are done with this, we are going to help you in resume building and giving the real world projects for implementation. So when we talk about these real world projects for implementation, this is extremely important part of the training. So we are going to give you the requirements and we'll give you the expectations or the expectations of the deliverables. Then accordingly, you are the one who is going to create the services, building the pipelines, creating the databases, executing and monitoring and tracking everything that you are going to do. And we are like a shadow to help you out how this needs to be implemented, right?